Hi everyone, welcome to the final video in this series going through exam questions on redox titrations. So this question here is another one where they've got a fair bit of information. Let's just go and have a look at the question here. So it says a 25 centimeter cubed sample of river water was analysed using the procedure. Titration required such much amount of thiosulfate. Calculate the DOC of the sample of river water. Okay, we need to, what's this about? We do actually need to read this, it looks like. So the DOC is the dissolved oxygen concentration. It's important for aquatic life. If it falls below 5 milligrams per decimeter cubed, most species of fish cannot survive. We can determine the DOC in water using the procedure below. So the river water is shaken with aqueous Mn2 plus and alkali. Okay, yeah. So there you go, oxygen, Mn2 plus alkali. It oxidizes Mn2 plus to Mn3 plus. So we get this manganese hydroxide. Okay. The precipitate is then reacted with potassium iodide, which is oxidized to iodine. Okay, and then you titrate the iodine against the thiosulfate. Okay. So this is just another iodine and thiosulfate one, but it's got a bit of manganese in there as well. It's not manganate ions, but it's going to follow the same pattern, right, where we do some sort of reaction first and then react that with iodide ions to make iodine and then titrate the iodine against the thiosulfate. Okay. So let's do the same thing. Let's go and look for some numbers. We've got this, we've got 25 centimeters cubed there. Where else have we got numbers? That's it really. This is all just a bunch of ratios, isn't it? And then this 5 milligrams per decimeter cubed is going to be important, isn't it? That's what we want to calculate. Okay. Right, so we'll start at the bottom again. We're going to start with this. So we're going to do our 24.6 over 1,000 into decimeters cubed. Times this by 0.001. That's going to give us the moles of the thiosulfate. 24.6 divided by 1,000 times 0.001. And it's 2.46 times 10 to the minus 5 moles of the thiosulfate ions. Right, then we want to do the ratio. So we want to go from the thiosulfate to the iodine. So the ratio of thiosulfate to iodine is 2 to 1. So therefore we've got this many moles divided by 2. So just divide that by 2. 1.23 times 10 to the minus 5 moles of the iodine. Right, so now that we've worked out the iodine, where did the iodine came from here? Okay, so what we can do now, crikey, we just have to do the ratio like 1,000 times in this question. So we've worked out the thiosulfate, looked at the ratio to get the iodine. That iodine has come from there. So now we can do the iodine to get the ratio of something else. Eventually we want to get back to the oxygen, don't we? That's what we want to know about. So we need a link between this equation and this one. And it's this manganese hydroxide precipitate, because that's come from there, hasn't it? Okay. So we now want to do the ratio of iodine to this. So if we do iodine to MnOH3, this is if we look at this equation, so it's a 1 to 2 ratio. So we're going to times this by 2 to get back to the same number again. This always feels a bit annoying when you end up back at the same number. You think, well, that was a waste of time, wasn't it? But there you go. So that is the moles of that. And now we need to do the ratio again. So now we can do the ratio of this thing to the oxygen, which is the thing that we want. So it's a 4 to 1 ratio with the oxygen. So we're now going to take that number and divide it by 4. So I had that, so I need to times that by 2 to get that, and then divide that by 4. So 6.15 times 10 to the minus 6 moles of oxygen. Okay. Right, so we've now got the number of moles. Here, what can we do here? So we want to work out the concentration in milligrams per decimeter cubed. Okay, so if we've got the moles, this is concentration, isn't it? So if we want to get concentration, we just do moles divided by volume. Okay, and that will give us concentration in moles per decimeter cubed, and then we can convert that into milligrams. So the volume was 25, right? So we can divide by that. So let's do, I'm going to run out of space here. 6.15 times 10 to the minus 6 moles divided by, it was in 25 centimeters cubed, wasn't it? So divide by 25 over 1,000. So we're going to do that, divided by 25 divided by 1,000. So it's 2.46 times 10 to the minus 4 moles per decimeter cubed. Okay, so now we've got per decimeter cubed, that's good. So now we just need to convert from moles into grams. Then it being grams per decimeter cubed, and then we can just divide by 1,000 to get into milligrams per decimeter cubed. Okay, so to go from moles to grams, we need to use the relative formula mass. So the I really am going to run out of space. Let's do this up here. So the MR, let's put a little box in here. The MR of O2 is 32 grams per mole. Okay, it's 2 oxygens, isn't it? So now we're going to do that times by this. So 2.46 times 10 to the minus 4 moles per decimeter cubed times 32 grams per mole is 7.872 times 10 to the minus 3. That's now in grams per decimeter cubed, right? Because the moles and the grams per mole cancelled to give us grams. So now we need to do this in milligrams per decimeter cubed. So, and this is where we need to think really carefully. If we've got this many grams, well, a milligram is smaller than a gram, isn't it? So if I've got 10 grams per decimeter cubed, I'm going to have more milligrams. Because milligrams, so I need to times by 1,000 to get it into milligrams, not divide by 1,000. Yeah. So I'm going to times this by 1,000. It's just going to get rid of that. It's going to be 7.872. So times by 1,000, 7.872 milligrams per decimeter cubed. Did it say? It didn't say anything about significant figures or anything here, did it? So we're okay. So that was a bit all over the place. Can we help out the examiner here just to help us mark it? Let's just say that number has gone there. And then let's calculate that, and that number's gone there. Okay. Right. That wasn't too bad. Bit of an odd one, but we got there. What else do we have to do now? Comment on whether there is enough dissolved oxygen for fish to survive. Okay, what did it say? It said if it falls below 5, then the fish can't survive. And we had 7 point something, didn't we? So we can say, what was it? 7 point, where's it gone? 7.872. So 7.872 grams per decimeter cubed is greater than 5. So there is enough dissolved oxygen for fish to survive. Oh gosh, my writing's getting terrible. Right. Okay, right, it then says the presence of nitrate ions interferes with this method because these ions can also, this is not our normal nitrate ion, this is nitrate 3, I should say, sometimes called nitrite, can oxidize iodide to iodine. During the reaction, a colourless gas is produced with a molar mass of 30 grams per mole. Okay, so if it's, I mean, we haven't got a huge number of choices here, have we? What have we got? We've got nitrogen, oxygen, iodine. Well, iodine's atomic mass is like massive. What is it? It's like 100 and something. Yeah, iodine's 100 to 126, so it's definitely not going to be that, is it? So it must just be nitrogen and oxygen. And, well, that's it, isn't it? Nitrogen's 14, oxygen's 16, so that's 30. So it's just NO. Okay. Right, and then it says write an equation for the oxidation of iodide ions by aqueous nitrate 3 ions. Okay, so we just need to write this equation. So it's iodide ions with these aqueous nitrate 3 ions, so that's this NO2 minus. Okay, and it says, well, what did it say? Nitrogen energy minus can also oxidize. So oxidizes iodide to iodine, so it's going to make I2. It's going to make this NO, isn't it, that we talked about, so it's going to make that. And it says hydroxide ions are produced as well. So so there's hydrogen here, so there must have been hydrogen in the product, in the reactant somewhere, so we must have had water. We're not going to have H plus ions, are we? We don't want H plus ions and OH minus ions in the same reaction. That's definitely dodgy. Okay, and this is definitely a redox reaction, isn't it? So we need to think about the oxidation numbers. So let's have a look. We're going to have hydrogen here as +1, oxygen's -2, iodine here is obviously -1, nitrogen here is 3, it told us that, that's +3, oxygen's going to be -2, 2 lots of -2 is -4, so that's why it adds up to -1. Iodine's going to be 0. Here oxygen's -2, so the nitrogen must be +2, and -2 and +1 as usual. Right, so what's going on here? We've got iodine. It's going from -1 to 0, so that is being oxidized. And then the nitrogen is going from +3 to +2, so that's being reduced. Right, so to build up this reaction then we need to make sure that the elements that are undergoing redox are balanced. So the nitrogen, I've got 1 and I've got 1, that's fine. But with the iodine, I'm going to need to put a 2 here to make sure that's balanced. So then we want to look at the total oxidation and reduction. So iodine's going from -1 to 0. So therefore it's being oxidized, so it's losing 1 electron, but there are 2 of them, aren't there? So overall we're doing -2 electrons, 1 for each iodide ion. And then with the reduction here, the nitrogen is going from +3 to +2, so it's gaining 1 electron. And there's only 1 of those. So this isn't balanced, then this bit's going to have to be times by 2. Okay, so I'm going to have to put a 2 there and a 2 there to make sure that the total amount of oxidation balances the total amount of reduction. Right, and now I can just look at the balancing to balance everything else. So iodines are fine, nitrogens are fine. What have we got? Oxygen, I've got 4, I've got 5 on this side, and I've got 3 on this side, so I need more oxygens here. Yeah, this might be a bit awkward again. So what have I got? 5 oxygens. So if I've got 2 there, that needs to be a 3. But that then gives me 3 hydrogens. That's never going to, this is always going to be an even number of hydrogens, isn't it? So let's make this a 4. And I've got 4 hydrogens, so that needs to be a 2. And then I've got 2 oxygens there plus 4, so I've got 6 oxygens there, 2 and 4. Okay, that's not too bad. That should be it. Let's just check the charges balance as well. 2 minus and 2 minus. So it's 4 minus there and 4 minus there. Lovely. Let's just write this out again, just so it's nice and clear. Okay.